Today's lesson is on factoring expressions. Factoring expressions is just the opposite of distributive property. To factor an expression, we will find the GCF, or the greatest common factor, of all terms. We will put the GCF on the outside of a set of parentheses and divide each term by the greatest common factor and put the new terms inside the parentheses. Okay, so let's get started. In example 1, we can see we have 8a plus 4. We're going to start with the coefficients. The coefficients are 8 and 4. We need to find their greatest common factor. Now, one way to find the greatest common factor is to actually use the factor tree. So this is something you did in 6th grade. So let's go ahead and use the factor tree on 8 and 4. Basically, we take each of those numbers and we're going to break them down into only their prime numbers and determine what they have in common. So if I break down 8, I can break that down into 2 times 4. 2 is a prime number, so I'm going to go ahead and circle it. 4 can be broken down into 2 times 2. Once we have all of the prime numbers, I'm going to write them near the bottom, 2 times 2 times 2. I can tell the prime numbers because those are the numbers I circled. Now let's break down 4. 4 can be broken down into just 2 times 2. So its prime numbers are 2 and 2. 2 times 2. Let's see what they have in common. It looks like they have 2 2's in common. So if I multiply 2 times 2, I get their greatest common factor, which is a 4. So if the greatest common factor is a 4, I'm going to move on to step 2. I'm going to leave the 4 on the outside of parentheses. Now notice that only 8 has a factor of a right next to it, but the 4 didn't have one. So I can't pull out a as a greatest common factor. So the only thing they have in common is that factor 4. So now I'm going to leave it on the outside of parentheses. So 4 times what is equal to that 8? That would be a 2. And because I have the a right next to it, I need to include that. So in other words, if we think about what we did with distributive property and I multiply these two, I get that 8a. So far I'm doing well. I'm going to leave the addition sign, and then I'm going to ask myself 4 times what number is equal to 4? That would be a 1. And I finished. I can check this by actually applying distributive property. So this is my answer, and now I'm going to check it. And I do that just by applying distributive property. 4 times 2a is 8a. 4 times 1 is 4. So it does check out. So the factored form of 8a plus 4 is equal to 4, open parentheses, 2a plus 1. Let's move on to the next example. In this example, I have 3.5 m subtract m times n. So you can see I only have a coefficient here of 3.5. I do have a coefficient right here, and it's actually 1, but it's invisible. So when I take a look at the variables, the m and the mn, they have an m in common. So the greatest common factor is just the 1m. So I'm going to pull it out and move on to step 2. I'm going to open up parentheses and ask myself m times what value is equal to 3.5m? Well, that's just 3.5. If I check it really quick, m times 3.5 is 3.5m. I'm going to keep the subtraction sign there. Then I'm going to ask myself m times what value is equal to mn? Well, that's just an n. Again, let's check our answer by applying distributive property. M times 3.5m is 3.5m. Keep the subtraction sign. M times n is equal to mn. So it does check out. So my answer is right here, m, open parentheses, 3.5, subtract n, closed parentheses. Let's try a couple more. In this example, it looks like I have a 14 and a 21. So let's start by finding their greatest common factor. To do that, we will utilize the factor tree. First, 14 can be broken down into the prime numbers 2 times 7. Since they are both prime, I'm going to go ahead and circle them. For 21, I can break that down into prime numbers 3 times 7. Now I'm going to look at them and see what they have in common. The prime factorization of 14 is just 2 times 7. The prime factorization of 21 is 3 times 7. So if I compare them, they have a 7 in common. So that must be the greatest common factor. So let's leave 7 on the outside of the parentheses. Since only the 14 has an x and the 21 does not, I cannot put an x next to the 7. So I'm just going to immediately open parentheses. 7 times 2x is equal to that 14x. I will keep the addition sign. 7 times 3 is equal to 21. So there's my final answer. I can, of course, go ahead and check it by applying distributive property. 7 times 2x is 14x. Keep the addition sign. 7 times 3 is 21, and that's exactly what I started with, so I know my answer is correct. Let's try example D. Now we have two coefficients. They're both invisible ones in front of these variables, so I don't need to worry about that. If I look at the variables, this term has a y, and so does the second term. So the greatest common factor then is just equal to a y. So I'm going to pull out the y, open parentheses, and leave everything left inside of parentheses. So y times 1 is equal to just y. Keep the subtraction sign. Y times x is equal to xy. And my answer, it looks like we're already finished. Let's go ahead and see if it checks out by applying distributive property. Y times 1 is equal to y. Keep the subtraction sign. Y times x is equal to xy. And it does check out. So let's try a couple more. In this example, I have 3 terms. There's the first one, second, and third. So I need to find the greatest common factor of 12, 16, and 10. So I'm going to start with the 12. I can break 12 down into 2 factors. Let's say I use 3 and 4. There are other factors of 12. You could use 2 and 6 if you wanted to as well. 3 is a prime number, so I'm going to circle it. 4 can be broken down into 2 times 2. Since those are prime, I'm going to circle those. So the prime factorization of 12 is 2 times 2 times 3. If I actually multiplied those, I would get 12. Now let's move on to 16. I'm going to break down 16 into, let's say, 2 and 8. You could also use 4 and 4 and still arrive at the same answer. Since 2 is a prime number, I'm going to circle it and break 8 down into 2 times 4. Again, circle the 2, it's a prime number. And finally, 4 can be broken down into 2 times 2. So it looks like we have 2 times 2 times 2 times 2, which does equal 16. My last number is 10. That is equal to 2 times 5, which both happen to be prime numbers. And so that is just 2 times 5. Once you're done finding the prime factorization of each coefficient, now compare them. They all have at least 1, 2, and that's the only thing they have in common. So it looks like our greatest common factor is going to be a 2. So I'm going to pull out a 2. They don't have any variables in common because these are all different. So I'm going to immediately open up parentheses. So now I'm going to ask myself, 2 times what number is equal to 12? That would be 6, and I can check it as I go. I definitely need an A right next to it because when I multiply, I want to make sure I equal 12A. 2 times 6A is 12A, so I know I'm right so far. I will keep the addition sign that they have there. 2 times what number is equal to 16? Well, 2 times 8 is equal to 16. So I can go ahead and write that there as well. And because it has a b next to it, I need to add that. So 2 times 8, b is 16b, so I'm right so far. Keep the subtraction sign and then ask yourself, 2 times what is equal to the 10? That would be 5, and you need a c right next to it. And there you have it. There's my final answer. And of course, I can always check it by applying distributive property. If I go ahead and check it, it looks like I'm going to do it down here because I'm out of room. 2 times 6a is 12a. Keep the addition sign. 2 times 8b is 16b. Keep the subtraction sign. And 2 times 5c is 10c. Since this is exactly what I started with, I know I'm correct. The last one, this one says try on your own, so you can go ahead and give it a try. I will also do this one. First thing we have to do is find the prime factorization of the coefficients, which are 12 and 36. So if I break down 12, that could be 2 and 6, or you could use 3 and 4. 2 is a prime number. 6 can be broken down into 2 times 3. So that gives me 2 times 2 times 3, which of course is 12. As far as 36, let's break that one down as well. 6 times 6 is 36. Neither of those are prime numbers because I can still break them down into 2 times 3 and 2 times 3. And now we have all prime numbers. So the prime numbers of 36 are 2 times 2 times 3 times 3. Now let's see what they have in common. It looks like they both have a 2, and they have another 2, and then they each have a 3. So they have in common 2 times 2 times 3. So if I go ahead and multiply those 3 together, I get 4 times 3, or 12 is the greatest common factor. Okay, so let's go ahead and pull out 12. And it also looks like they both have an x, so I'm going to pull out the x as well. When I open up parentheses, 12x times what number is equal to 12x? Well, that would just be a 1. Keep the subtraction sign, and 12 times what number is 36? That would be a 3, and I need a y there. Okay, let's check our answer really quick. I'm going to apply distributive property now. 12x times 1 is 12x. 12x times 3y is 36xy. Since I arrived at what I started with, I know I'm correct. And that concludes this lesson.